Day everyone. So today we will be discuss all about the section 9. The topic is understanding and magnetism. So when we say magnetism, has been known since ancient times. So magnet is an object that has a special property to attract certain materials such as the iron, nickel, steel, and cobalt. So, si magnet is mag-attract lang siya sa made of iron, steel, nickel, and cobalt. So, si magnet is dili na siya mag-attract pag plastic and rubber na. So, pag made up, ganin na siya steel and nickel and cobalt iron, attract jud na sila in one another. So, according lang sa mga object na made of iron, nickel, and steel, and cobalt bago mag-attract si magnet. So, the ends of the magnet are where the magnet field effects is the strongest. So, sa ends sa atong magnet, for example, na atay magnetic bar. Makita ninyo dira sa PPT. So, kani si magnetic bar sa end ani nila is naay duha ka poles, which is mauna si South Pole o si North Pole. So, mauna sila ang magnetic poles. So, kaning naa sa gilid na with arrow-arrow, so mauna ang magnetic field. Like I said na naay duha ka pole ang magnet. So, naa si North Pole. Makasulti ta nga si North Pole is diri siya nga direction. It is a pole pag mag-point siya towards the north direction. Tapos si South Pole, it is a pole points toward the south direction. So, magsulti ta nga diri si South Pole pag ang iyahang points is towards sa south direction. Tapos makasulti ta nga mao ni si North Pole pag ang iyahang direction is naka towards sa north direction. Mo nang ilhanan sa South Pole and North Pole. So magnetic poles are different from the electric charges due to the fact that electric charges can be separated and insulated. However, magnetic North or South Pole cannot be separated and insulated. So, meaning ani, lahi siya sa electric charge o sa magnetic field. So, ang kalahian ani sila mga charge kasi electric charge is separated ang iyang charges. For example, kato itong gibuhat nga activity nga sudlay, i-rub nimo siya sa imuhang forehead tapos ang katong sudlay is makakuha siya electrons nga nagikan sa imuhang hair. Tapos ang katong pieces of paper mao to si proton. So, mautong pagdikit mo sa ilaha is mag-attract sila. So, meaning to say, ang ilang charges is separated by objects. Isa ka object mao ni si electron, then ang isa ka object mao to si proton. So, separated siya. Ang sa magnet manggod is dili siya separated. Like ang magnet is always dyan sila mag-uban, never dyan na sila magbulag. So, kaning si South Pole o si North Pole, always dyan sila mag-uban sa isa ka magnet. Never ni sila mag-break ang ilahang charges. Dili ka parehas sa electric charge is separated ang ilahang charges, separate si electron si proton. Ang kaning si magnet is mag-uban jud ni sila sa isa ka magnet, si South Pole o si North Pole. Mao nang kalahian sa duha which is si electric charge and si magnet. So, inani pag like poles, so repeal. Inani ni siya pag south to south is mag-repel jud. Wala attract nga nahitabo it because kapareha lang ang poles niya. Then kapag unlike poles is mag-attract jud siya to one another. Pag si electron o si proton, so mag-attract jud na sila into one another. Pag proton to proton, never jud basta same ang poles niya. Same lang gyapon na sa electric charge. Pag proton to proton, dili mag-attract. Pag electron to electron, dili jud siya mag-attract. So, si magnet kanila hilang ya is pag Pag South Pole to South Pole, wala attraction mahitabo. Pag North Pole to North Pole, wala siya attraction mahitabo. Pero pag differences ang pole niya, mao na si South Pole o si North Pole, na attraction mahitabo. So, na siya. So, magnets create a magnetic field around them. So, sama sa akong gisulti ganina, ang isa ka magnet is naadyo na siya magnetic field around them. So, si magnetic field mao na siyang is a object around the magnetic field. Mao na si magnet. So, it has not been shown to be possible to end up with a single North Pole or a single South Pole, which is the monopole. So, when we say monopole, mao na siya ang single pole lang. For example, isa ka magnet. Isa ka magnet tapos ang isa lang ana is si monopole lang. So, wala na siya nag-exist. Sama sa akong gisulti ganina nga ang isa ka magnet is always jud mag-uban si North Pole o si South Pole. So, si monopole is never, wala siya nag-exist. Okay, si monopole, ang meaning mo sa monopole is single pole lang. Halimbawa, isa ka magnet is si North Pole lang dira. So, wala siya nag-exist, ana. So, akong kisultingin na mag-uban jud si North Pole o si South Pole sa isa ka magnet. So, walay monopole nga nahitabo. So, let us move. So, next slide. If you cut a magnet in half, so magnetic field always exists in pair. So, meaning ani, pag natay isa ka magnetic bar, mao ni si magnetic bar. Pag ato na silang putulon, so unsa possible na mahitabo? Naabay monopole na mag-exist? So, like I said kanina, nga walay monopole na mag-exist. Bisan pag i-break nimo ng isa ka magnetic bar, i-break nimo into two, so mag-create gyapon na siya og duha ka pole. Mao ni si South Pole o si North Pole. Never yun na sila mag-break. Bisan pag putlon pila na ka pieces na putlon nimo ang isa ka magnetic bar, mo create gyapon na siya og North Pole o South Pole. Never yun na sila mag-break. Ang kanang duha ka pole kana. So, si magnetic field always exists in pair. So, bisag putlo nimo na sila, mag-exist dyan na si magnetic field. So, sama sa konsulti, sa isa ka magnet is, na dyan na siya magnetic field, mag-create dyan na siya o magnetic field. So, pag putlo na nimo ang isa ka magnet, sa isa ka magnetic bar, putlo nimo, so mag-exist dyan siya o duha ka magnet. So, different shapes of a magnet. So, ang mga different shapes sa magnet na atay magnetic bar, which is katong straight lang siya. So, mauna si magnetic bar. Tapos, inang tag horseshoe magnet, mautong katong letter U nga magnet. Nga makita mo sa akong slide. Mauna si horseshoe magnet. Tapos, this si desk magnet. Mauto siya so, kung masulti tag desk magnet, mo na siya, ang mura piso lang siya. Ang style sa ma-identify nimo si North Pole o si South Pole ani, ang sa atubangan mo na si South Pole, ipatilikod na pud nimo si desk magnet, mao na si North Pole. So, inana siya pag-identify sa South and sa North Pole niya. So, kana lang akong discussion. That could be all. Thank you.
Now let's talk about magnetic field lines, properties of magnetic field, and Earth's magnetic field. Now, what is magnetic field lines? Magnetic field lines are fictitious lines that runs around a magnet. The density of the field lines indicates its magnitude. The magnetic field is stronger towards the south and north poles of the magnet, and it weakens as it goes away from the pole. Also, magnetic field lines is only a visual representation that is used to represent the magnetic field. Now let's talk about the properties of magnetic field lines. These are the properties of magnetic field line. The tangent drawn to the magnetic field lines gives the direction of the magnetic field. The line such as the tangent at any point of it gives the direction of the magnetic field at that point is called the magnetic field line or the magnetic line of force. The next properties of the magnetic field lines is the closeness or the density of the field lines is directly proportional to the strength of the magnetic field. Meaning, a test charge placed anywhere will feel a force in the direction of the field line. This force will have the strength proportional to the density of the line. The other thing is if it means that if one quantity goes up by a certain percentage, the other quantity goes up by the same percentage as well. The third properties of the magnetic field lines is the magnetic field lines appears to emerge or start from the North Pole and merge or terminate at the South Pole. Meaning, mugawas siya sa North Pole and then masulod siya sa South Pole. The four properties of the magnetic field lines is field lines have both direction and magnitude at any point on the field. Therefore, magnetic field lines are represented by vector. It means the magnetic field is described mathematically as a vector field. This vector field can be plotted directly as the set of many vectors drawn on the grain. A vector is a quantity or phenomenon that has two independent properties, magnitude and direction. The fifth properties of the magnetic field lines is they denote the direction of the magnetic field, meaning they indicate the direction of the magnetic field. So the direction of the magnetic field at a place can be determined by using a compass needle. This is an example. A compass needle placed near a magnet gets deflected due to the magnetic force exerted by the magnet. The north and the needle of the compass indicates the direction of the magnetic field at the point where it is placed. The six properties of the magnetic field lines is the magnetic field is stronger at the poles because the field lines are denser near the poles. This implies that the density of the field lines indicates the strength of the field. The closer the magnetic field lines are, the stronger the magnetic field at that point. The next topic we will talk about is all about the Earth's magnetic field. The magnetic field is generated by electric current due to the motion of convection currents of a mixture of molten iron and nickel in Earth's outer core. These convection currents are caused by heat escaping from the core, a natural process called a geodynamo. The Earth's magnetic field, also known as the geomagnetic field, is generated in our planet's interior and extend out into the space, creating a region known as the magnetosphere. Without the Earth's magnetic field, life on Earth as we know it will not be possible as it shields us of all the constant bombardment by the charged particles emitted from the sun, which is the solar wind. Earth has two sets of poles, geographic pole and magnetic pole. Earth's magnetic field can be visualized if you imagine a large bar magnet inside our planet, roughly aligned with the Earth's axis. Each end of the magnet lies relatively close, about 10 degrees, to the geographic north and south poles. Earth's invisible magnetic field lines travel in a close continuous loop and are nearly vertical at the Earth's magnetic pole.
There are three things that can cause a magnet to lose its magnetism. 1. is hitting the magnet. The heat makes the electrons move faster and faster, and as they get jumbled up, the magnetic force dissipates. Another is putting the magnet in a demagnetizing field, one that cancels out the magnet strength. If you've ever had a magnetic strip on a card in your wallet stop working, this may well be the cost. Finally, dropping a magnet orientation and the magnetic force. So we've learned what magnetism is and how it behaves, how charge and motion creates a magnetic field. And remember that a charged particles has to be moving through a magnetic field in order to experience no movement, no force. Now let's look how to calculate a magnetic force. Let's say we have a magnetic field and there's an electron moving around in the field. Ang arrows diha is the magnetic field pointing to the left, and the electron is kanang naay symbol nga E-. The electron is moving fast at a velocity of 2 times 10 to the 5th meters per second upward. In a magnetic field, strength 4 Teslas pointing from right to left. The question is, what will happen to the electron? Will it feel a force? And if it does, how much? The magnitude of the magnetic force that a moving charge feels that depend on the three things: the charge Q, the charge velocity, the V, and the magnetic field's strength, which is the B. Once we know these three quantities, we can solve for magnetic force by multiplying them all together. In this case, we've been told how fast the charge is moving and strength of the field it is in. And remember that we know what the charge of an electron is. Negative is 1.6 times 10 to the negative 19 coulombs, bringing it all together to solve for a magnetic force. Magnitude on the electron. We have the magnetic force on a charge equals to the charge magnitude times its velocity times the magnitude in which the charges is moving. Plugging in all of your numbers, we find that this magnetic field exerts a force of 1.3 times 10 to the negative 13 newtons. Now, which way does the magnetic force? We know that our charge is moving upward and it's negative.